As you can see here, we have multiple nodes. We have the westbound terminal and the eastbound terminal in this diagram. These terminals will add and drop traffic, but they stop here. They add here and then they drop here. When it gets to the AMP site, these sites just regen the signal, the DWDM signal, across the DWDM path. And mind you that all these nodes are geographically separated on these fibers approximately 40 to 50 kilometers away from each other in different facilities. So in reference to the add drop node, you can add traffic on the down coming from the east terminal, or you can drop traffic on the west terminal, or you can have traffic from the west terminal pass straight through all the way to the east. So the add drop has the capability of dropping traffic, but it doesn't have to. It can pass through. And the other AMP site here is just to regen the signal. When it comes to the Ciena Corestream device, it is very important in perspective of what node you're logged into to where your eastbound and westbound terminal is at. Because that's really going to tell you where you need to figure out your span problem, or check your light levels, or determine where traffic is having issues at. In this diagram here, I have my west terminal highlighted in red there, and then my east terminal highlighted in red. The transmit and receives on the nodes are in respective to the eastbound transmit and receive and westbound transmit and receive. So this is my west terminal traversing east. So this will be my eastbound receive, and this will be my eastbound transmit, because I'm transmitting towards the east. And it'll be the same way across the entire span until it reaches the east terminal. And this will actually be your receive. It'll be your receive card coming in there. It'll be labeled receive. Now your transmit is going to be labeled transmit, but this one's heading westbound because it's heading to the west terminal. So this will be your westbound receive and westbound transmit, and it's the same throughout the entire span here. And when it gets here, this is your optical receive into the terminal. If I were to say have a fiber optic span problem in between these two nodes, where it was a light level degrade of some sort or a fiber optic cut, and I need to check the light levels on the AMP site here and the add drop node here, I would want to check the light levels on the receive side coming into the node. And it's important that I understand that determining which one's east side and which one's west side. So in this scenario, this one's going to be my eastbound receive coming in. So ERX. That's my eastbound receive, and then I'm going to have to log into this node and pull my westbound receive here at this point. And I've done it multiple times where I get mixed up on my eastbound and westbound, and I actually end up pulling the PM here when I'm supposed to be pulling it at this point, and vice versa. I'll pull it over here versus my actual eastbound. I'll pull it on the westbound because I'll get my eastbound and westbound mixed up. So as you can see, if I pulled a fiber optic light level at this point, that's not even in reference to the actual problem that I'm seeing here in my fiber optic degrade. So it's very, very important that you understand the eastbound, westbound transmit and receive.